Okay, in the second half of 1.3, we're going to learn all about the properties of equality and then use those properties to solve equations. So this first part, we're just going to jot down the properties really quick. So the reflexive property looks like this. Very, very, very simple. Reflexive means a number is equal to itself. It's as simple as that. The symmetric property looks like this. If A is equal to B, then B is equal to A. And when we do something like this, we don't literally mean like just a single number. You can mean like a whole equation. And this basically means you can flip the equation back and forth. So say, like from the previous video, say you had something like this, you could write it in this direction, or you could say 19 equals 7y minus 2. So the symmetric property basically says you can flip the two sides of an equation. The transitive property is kind of a cool one. This one says if A equals B, and B equals C, then A equals C. So if A is equal to B, but then we know that B is equal to C, like it says, it must be that A is equal to B. Kind of that they're all equal to each other. That's what the transitive property says. And then substitution works like this. If A is equal to B, they may replace each other. And so substitution will come in a lot when we're trying to solve systems of equations later on in the year. So basically, again, let's go back to this example. Say we knew that 7y minus 2 was equal to 19. If you ever saw 7y minus 2, you could replace it or substitute it with a 19. Okay, so just some very quick properties. Now we're going to use those to solve some equations. Okay, example 3, we're going to see if we can recognize the properties. Part A, the two sides are exactly the same. And whenever you're just showing that the two sides are the same, of course they're equal, that's the reflexive property. And then part B says if 9 is equal to x, it must be that x is equal to 9. And that's exactly what we've got written out here for the symmetric property. It says that you can flip the two sides. So for part B, it represents the symmetric property. So you'll see example problems in the homework that'll ask you to pick out which one of those properties you're using. Okay, now, even more important properties of equality, the addition and subtraction, as well as multiplication and division properties, we're going to use these in the rest of the section to solve equations. So these I think you've definitely done before, especially in Algebra 1, maybe even Intro to Algebra. So the addition and subtraction property says this. If A is equal to B, so we're going to start with that. If A is equal to B, so say you start off with an equation and you know the left-hand side is equal to the right-hand side. Okay, then A plus C is equal to B plus C, and A minus C is equal to B minus C. So once that's written down, I'm going to explain it. Okay, so you start off with an equation. What the addition property of equality says is if I add the same thing to both sides, the two sides are still equal. Or the subtraction property says if I subtract the same thing from both sides. So you've done this for years in algebra. This basically says if you add the same thing to both sides or subtract the same thing from both sides, then you still have the equality. Whatever you do to one side, as long as you do it to the other, the two sides are still equal. And then multiplication, basically the same. Starts off like this. If you know that A is equal to B, you can either multiply or divide both sides by the same thing, and you keep the equality. So then A times C is equal to B times C, so you can multiply both sides by the same thing, or you can divide both sides by the same thing. This, it's very, very, very important to note that you're not dividing by 0. So the division property holds as long as you're not trying to divide both sides by 0, because we know that that is something that's not allowed. Okay, let's look at some examples here. So we're going to use those properties to solve equations. I'm going to walk through this kind of slowly because it may have been a year or two since we've solved equations. We're going to start with one-step equations in example 4. So this one we've got m minus 5.48 on the left-hand side. So remember your end goal is to get the variable by itself. So you want to be able to say m equals and then whatever it equals. And then we'll check your solution. I'll walk you through how to do that on the calculator. It's actually pretty cool. So m minus 5.48, basically what you want to do in these one-step equations is you want to see which one of the four operations is happening, and then you want to do the opposite. So m, our variable, is being subtracted by a number. And so the opposite of subtraction is addition, so you want to do that. So what I'm going to do is do the opposite of subtracting 5.48. I'm going to add 5.48. The addition property that we just wrote down says we have to do the same thing to both sides. So if I'm going to add 5.48 to the right, to the left, I have to add it to the right. So what happens on the left is the negative and the positive. Remember, those are called inverses of each other, which means when I add them together, I get 0. So on the left-hand side, I have m and then plus 0. So that's just m. So these two have effectively canceled each other out, and then I add these. So make sure you kind of keep the decimals lined up. So the 2 and 8, when I add those together, I get 0, and then carry the 1. 1, 0, and 4 gives me 5. Then line up the decimal place there, and then 0 and 5 gives me 5. So we add that together, we get 5.50. Now here's how we're going to check our answer. Like I said, this is pretty cool. So go into your calculator, and you want to open up a new document, or you can just add a page to your old one. You don't ever really need to save. So we're going to go with a calculator page. So here's what we do. Take your answer, type it in. So we think our answer is 5.50. I say we think just because we haven't officially checked it yet. And then there's this little button. See where the 9 is? Look up above it, and there's a button that says variable right here. Sorry, my black pen's blending in. And then there's a blue words that say STO with an arrow. So you want to hit the control button right here, and then hit this button right here, and you should get an arrow. And then type the letter M, which is our variable, on the number pad. So down here, type the number or letter M. So that's what your screen should look like. So then hit enter. So now what's happening is that it thinks the letter M has a value of 5.5. Then step 2 is you type in this equation, the original equation exactly as it's written. So we're going to type M minus, which is over here on the right hand side, minus 5.48 equals, and the equal sign is right over here next to the letters that say trig, and then 0.02. So we're just checking to see if our answer is right. Go ahead and hit enter and see how it says true. If we had the wrong answer and tried to type it in, it would say false. So that's a pretty quick check you can do to see if your answer is right or not. Okay, so our answer is right. We checked our solution. So next one, part B, we're trying to get t by itself. So remember, you do whatever the opposite. So we're multiplying by 1/2, or you could say that you're dividing by 2. Either way. So we want to do the opposite. So when you've got a fraction like this, what you want to do to get it to cancel out and get the t by itself is you want to multiply by its reciprocal, which is 2, or 2 over 1. And whatever you do to one side, you must do to the other. So 1/2 times 2, those are inverses of each other, so you just end up with 1. So all you have left is that t. And then 2 times 18 gives you 36. Okay, so let me run you through that check one more time. So you type in the number 36, and then hit Control and then this variable button, store it in as t, and then type the equation. 18 equals, and then type 1/2. So if you hit Control and then hit the division sign, you can get a little fraction template. So 1/2, and then times t. Check your answer, and it is true. So that's how we know we're right. Okay, in example 5, we're going to solve some multi-step equations here. So quite a bit more complicated. What we usually start off with is distribution. So on the right-hand side here, see how we have a 3 and a 2? Those need to be distributed. So I haven't done anything with the 53. I'm going to distribute this 3. So 3 times y gives me 3y. And then 3 times negative 2 minus 6. Then I'm going to distribute this negative 2. So negative 2 times 3y is negative 6y. And then careful here, negative 2 times negative 1 gives me a positive 2. Okay, so now on the right-hand side, I'm going to combine up like terms. So I have a 3y and a negative 6y, which give me a negative 3y. And I can also combine this negative 6 with this positive 2. That gives me a negative 4. Okay, so here's the equation I have so far. I've got 53 equals negative 3y minus 4. So remember, your end goal is to be able to say y equals, and then a number. You want to get the y totally by itself. So the first thing you're going to do is do the opposite of what you see here. This is subtraction of 4, so the opposite of subtraction is addition. So I do that to the right, which means I have to balance on the left. So here I've just gotten the 4's to cancel out. Here I'm going to add these together, and I get 57 equals negative 3y. And then right now we're being multiplied by a negative 3. The opposite of multiplying is to divide by negative 3. Okay, so we get 57 divided by negative 3, and if we simplify that down, let's see, we know the answer is going to be negative, and then we get 19, negative 19. Okay, so we can plug that in and check it out as well. So type in negative 19 and store that in as y, and then plug in your equation. This is going to be a little bit more complicated. So 53 equals 3, and then the parentheses are right down here next to the 0. So parentheses, y minus 2, close the parentheses, minus 2, open parentheses, 3y minus 1, and then close. So that turns out to be true as well. So we're doing pretty good. Okay, so box that in. And then this one. This one's a little bit more complicated because I have fractions. So 3/5 here, these 5s are going to reduce down. So 15 divided by 5 is 3. And then 3 times 3, we get 9d. I can do the same thing here. 20 divided by 5 is 4, and then times 3 is 12. Okay, then here distribute a negative 1/6. Negative 1/6 times 18 means I'm dividing 18 by 6, so that gives me 3. And then negative 1/6 times negative 12, I know it's going to be positive, and 12 divided by 6 is 2. Okay, so I'm doing really similar things here. I'm going to combine up like terms. So positive 9d and negative 3d, I get a 6d. And then 12 plus 2 is 14. I'm just combining like terms on the left-hand side right now. Now I'm going to start moving back and forth. So here I have addition of 14. The opposite of addition is subtraction of 14. Do that to both sides to keep the balance. These will cancel out. I have a 6d left. And then I can subtract here and I get 24. And then the last thing to get the d by itself is to do the opposite of this multiplication, which is division. So I'm going to divide by 6. This reduces down to 1, so it's just a 1d, which is the same as just d. And then I'm left with 4. Okay, so you could run through and check that on your calculator the same. I just want to make sure I get through these. So here's a quick formula problem. Formula is given right here, where L is the slant height and R is the radius. We want to solve the formula for L, which means basically doing any steps that we can to get this L by itself. Okay, so first thing we're going to do is get rid of this addition. Remember, the opposite of addition is subtraction. So do that from both sides. So on the left I have s minus pi r squared. Now these are all variables, so they don't have any like terms. So you really can't simplify, you're just kind of rearranging. And then again, we're trying to get this L by itself. It's being multiplied by pi and r, so we can divide both sides. Okay, so these cancel. And just like I wanted to, I get the L by itself. And then this side really doesn't simplify. I can't cancel these out because I would have to be able to cancel them from this term as well, and I cannot. So all I'm doing right now is just rearranging my formula and getting a different variable by itself. So that would be your answer there. Okay, and my last is a standardized test prep question. So here's what I'm trying to do here. It says 4g plus 5 is equal to this. What is 4g minus 2 equal to? So basically, as a little shortcut, if you can start with this, we want this left side to equal this left side. So how do we get this to be a negative 2? Well, if we take 5 and we subtract 7, then we would end up with a negative 2. Okay, so I'm going to start with this right here, and I'm going to subtract 7 from both sides. Okay, so the left-hand side, I'll end up with 4g minus 2, which is exactly what I wanted. And then on the right-hand side, I have to subtract 4/9 minus 7. Okay, so 4/9 minus 7. There are plenty of ways to do this by hand. Keep in mind you would have a calculator on a standardized test. But what I want to do is get a denominator of 9. So I'm going to multiply by 9 over 9 so that these two have the same denominator. So I would have 4 over 9. And then 7 times 9 is 63. So I have 63 over 9, and then now that my denominators are the same, I could subtract those. So 4 minus 63 gives me a numerator of negative 59 over 9, and that matches with letter C here. Okay, that is the end of 1-3.